Hi, I'm Mr. Taru. We're going to be talking in this video about simplifying expressions and combining like terms. Now, an expression is kind of like an equation, but there's no equal sign or no inequality. It's just a collection of terms, numbers and variables that we're going to combine if possible. We're going to be looking for like terms. Now, like terms have the same variables in them, and each of those variables must be raised to the same power. So, let's say 7x plus 2x. Those are like terms because they both have a numerical value, which is here or there, whatever, and they both have an x. You know, really looking for like terms, all constants, all numerical, just straight values, 7, 2, 5, any number, set of numbers can be added together. When you look at terms, it's really more about what variables are in there. These two terms have the same variable of x, and they have the same exponents. Both of those exponents have an exponent of 1. Now, if I were to make this 7x and this 2x to the fourth, these are no longer like terms, even though they have the same variable. You cannot have different powers on those, or different exponents. So, like terms have to have the same variables in them, and each of those variables must be raised to the same power. Now, what is a term? A term is a number, like 7 plus 2x. Let's go to that. I dropped the x there. That's a term. Okay, a term is a number, or just a variable, or a product of a number and a variable, or even a couple of variables. You know, 2xy, that's a term. 2x, that's a term. Just 2 alone, that's a term. And now these are like terms, and that becomes 9. So terms are numbers, or a number, a variable alone, or the product of a number and one or more variables. And when you're looking at a polynomial, or when you're looking at an expression, the terms are separated by addition and subtraction. So just look for the plus signs. On each side you'll have a term, and you're good to go. So let's do some examples. So we have 4b minus b. Now, in regular practice of algebra, whenever you have just a variable with nothing in front of it, you might want to slip in a 1 there, just so you can see that numerical value. And you could very well just look at this and go, well, 4 minus 1 is equal to 3b. And that is certainly fine, and I'm sure that any algebra teacher would be happy, or algebra 2 teacher would be thrilled with you just doing, okay, 4b minus 1b is equal to 3b. Now, but depending on where you are in math, if you're learning how to combine like terms for the very, very first time, this video is probably going to get a little advanced for you because I'm going to jump up the difficulty here very quickly. But I have seen it in textbooks where they show adding like terms and how it's related to the distributive property. So if you've seen that, I'll show it to you, but I'm not going to do this for the rest of the video. Both of these terms have a variable of b, and since both of them have a variable of b, that can be factored out. And I can write this as 4 minus 1, and then wrap that in a set of parentheses and divide out the variable of b. And then 4 minus 1 is simply equal to 3b. You might have seen something like this. I'm probably abbreviating it a little bit too much. If you're using a textbook that talks about this distributive property and how it helps you add like terms, I'm simply going to be looking at the numbers out in front of the like terms and just combining them. 4 minus 1 is equal to 3. Okay, so let's do our next example. We have 5x plus 7 minus 2x. Okay, so we have like terms of 5x and 2x, but they're separated. Now, you have a choice. You can just move the terms around and put those x terms together, which I'll do in my first example, and then I'll rewrite this, I think, and show you another way of writing it. And it's going to look like this. It's going to be 5x, negative 2x, and then plus 7. Now you might be going, but that's subtraction, and subtraction is not commutative. And that's true. But if you look, I haven't really done the commutative property. I've moved the sign, that 2x is negative, I've moved the sign with it. It's not like I said that 5 minus 2 is equal to 2 minus 5, where I'm leaving the sign in the same place and moving the numbers around, because this is equal to 3 and this is equal to negative 3. That's not the same number. However, okay, just be aware I'm not using the commutative property. I'm moving the terms around. I'm rearranging them so my like terms are together, and I'm moving the signs with those terms. So I have positive 5 and negative 2x. These are like terms. And what I'm going to do for the rest of this video is I'm going to just use different shapes around the like terms to show you what I'm combining or adding together. So we have 5x minus 2x. 5 minus 2 is equal to 3x. And then we have a plus 7, and that's done. You've simplified the expression. Now it is simplifying. There's no equal sign. This is not an equation. So we're not going to find out what x is. We're not going to say x is equal to 5. And this is not evaluating. So we're not going to get a numerical value in our last line of work. It's not going to be like the answer is 10. Or, because it looks like 3 plus 7 is equal to 10. But this has an x and this doesn't. So these are not like terms. These are not going to go together. This is it. This is your answer. So when we get into algebra, every time we work with a problem, we don't necessarily get a numerical value as an answer. When we solve an equation, hopefully we will. But when we're evaluating, we're going to get a numerical answer. But with simplifying, we're just kind of trying to bring together as many of the terms, there's 3 of them here, into our expression. And I've got 3 terms here separated by the 1 addition and 1 subtraction into 2 terms, and then I'm done. There's nothing else to do. What I would normally show in class after the first couple of days of combining like terms and getting students used to it, normally what I'll do is I'll leave the expression in its original form, and I'll just circle or box in, or use some kind of random shape to just show the connection, show the like terms. This is 5x and negative 2x, these like terms. Positive 5 and negative 2, come together to make 3. And the positive that's here is for the 7, and it stays there. Okay? When you look for the sign of a term, you always look to the left. This 5 is positive, this 2 is negative, and thus 5 minus 2 is equal to 3. Okay, let's take a look at this one. Negative 3y minus, parentheses, 4y plus 3x. Now hopefully you're comfortable with something called the distributive property, which says when you have a set of parentheses, you take what's out in front and multiply it through. Well, I've chosen this problem to do with you because a lot of students will just go, well, there's nothing there, so let's grab the 3y, the negative 3y, and multiply it through the parentheses. But that negative number that's here is an actual numerical value. It's negative 1. And you only multiply or distribute through the parentheses what's immediately in front of it. What's right there, right against the parentheses, that's what you multiply through. The negative 3y, that's just going to sit there because it's separated by that minus sign. That negative 1, I'm going to multiply through this parentheses. So we have negative 3y, negative 1 and 4 is negative 4y. When you multiply a negative and positive number, it comes out to be negative. And negative 1 times positive 3 is negative 3x. So my parentheses are gone. Now I can combine like terms if I have any. And I do. I have negative 3y and negative 4y. So these like terms are going to go together. The x, well, x isn't y, so it's just going to sit there and kind of float down through the rest of the problem. When you start adding or subtracting, when you start combining numbers that have the same sign, with addition or subtraction, if you add, you move to the right on the number line. When you subtract, you move left. So we have a subtraction or negative 3. That's 3 spaces to the left from 0. Then we have a minus 4, so we're going to move 4 more spaces to the left. And when you're at 0, and you move left 3 and left another 4, if you're having trouble with your signs, it's going to be negative 7. Or when you add numbers that have the same sign, or when you're combining numbers that have the same sign, add those numbers and keep the sign. Now if you're multiplying, it'd be positive, but we're not multiplying. So negative 3 and negative 4 is negative 7y minus 3x. This has a y, that has an x. Those aren't like terms. Bam! I'm done. Moving on. Moving on to the next example. Negative 3x minus 2y minus 4 times negative x plus 7y. Again, every time I do an example, I'll step up on the difficulty. These both have a negative 1 that is in front of the parentheses, or at least that one does. This has negative 4. So we're going to multiply negative 1 through this parentheses, and we're going to multiply negative 4 through that parentheses. See how I'm capturing the signs to the left and pulling it through? You want to do that. Negative 1 times 3 is negative 3x. Negative 1 times negative 2y. Yes, if I were to cover this up, it's negative 2, right? You only say minus when I put something in front of it. So a minus sign and a negative sign, your graphing calculators won't agree, but they do act the same with these math operations. So negative times negative is positive. And now we got negative 4 times negative 1. Yes, there is a 1 there. Let's put that in there so you can see it. And negative 4 and negative 1, when you multiply, make positive 4. And negative 28y. We're going to add like terms. And I'm going to stick with my circling idea here. So we've got negative 3x and positive 4x. We've got positive 2y and negative 28. So these are going to come together. Negative 3 plus 4 is 1x. No need to really write the 1, but I'm going to for teaching purposes. Put these together, positive 2 and negative 28. So 28 minus 2 is 26. The largest number is negative, so I'm going to keep that negative sign, and we have x minus 26y. And that's it. Moving on. Moving on. What do we got left? We've got about 3 more examples left. We have 1/3 times n plus 4 plus negative 7n. Okay, well, we have a lot of brackets going on here, a lot of parentheses. We need to clean those up first if possible. And there's nothing in front of this parentheses to multiply through. There's no exponent. So really it's not doing much, and nothing at all to be honest. So we have n plus 4. Positive and negative is negative 7n. And this is an optional step if you want to rewrite it without the parentheses. And we have like terms of positive 1n and negative 7n. Well, 1 minus 7 is negative 6. So 1/3 times negative 6n plus 4. We're going to distribute that number that's in front of the parentheses. And don't forget when you multiply fractions, you go across the top. So we're going to have, well, let's make this look like fractions. Let me put this over 1 and this over 1. When you start working with fractions, just make everything look like a fraction. And when you multiply fractions, you go straight across the top and straight across the bottom. So 1 and negative 6 is negative 6. 3 and 1 is 3n. 1 times 4 is 4. And 3 times 1 is equal to 3. And what do we have? We have 6 divided by 3, or negative 6 divided by 3, which is negative 2n, plus 4/3. Bam! That's it. Moving on. All right, we got x, parentheses, 2 minus y, plus 5y, times x plus 4. So again, we have parentheses, we have numbers in front, and again, those are going to get multiplied through the parentheses. Only now it's a variable there. But you know what? I'm still going to do the same thing. It doesn't matter if that's an x or a 3. If there's a number in front of the parentheses and it's touching, it gets multiplied through. Unless, of course, you have an exponent you have to deal with first, but we don't. So we have 2 times x, which is 2x. Positive and negative makes a negative xy. And then we have, now you notice how I'm not writing the signs right away? I'm looking at the sign of what my answer is going to be. So I'm not writing this plus sign immediately. I'm going positive 5 times positive 1. Well, 5 times 1 is 5. So plus 5 xy. And then positive 5 times positive 4 is 20. So plus 20y. Look for like terms you can add together. This has an x, this has a y. Those aren't like terms. However, we have a negative 1xy and a positive 5xy. So these are like terms that have more than one letter, but they have the same letters, the same variables, and the same power exponents on those variables. So those are going to come together, and we get 2x, negative 1 and 5 is 4, and then plus 20y. Let's check our work, and we're good. Bam! That's it. Nothing else happens. And now, how did this simplify? We had all these parentheses, quite a long expression. When you look at our simplified version, there's no parentheses anymore. And it's kind of difficult to say what number of terms we have here with the grouping symbols, but we have 3 terms left and we're done. Again, terms are separated by addition and subtraction. 2 plus signs, so 3 terms. Our last example is going to be for combining or simplifying expressions, combining like terms. 1/2 2x squared minus y squared minus 4/3 times x squared plus y squared. Okay, just like before, a couple parentheses, numbers out front, get those plugged in. If you have multiple numerical values, if even one of them look like a fraction, it's not a bad idea to make them all look like fractions. So 1 times 2 is 2. 2 times 1 is 2, x squared, minus positive times a negative is negative. And when you multiply by 1, the numerical values don't change. So this will be minus 1/2 y squared, and then minus times a positive is negative, 4/3 x squared, and minus 4/3 y squared. So yes, we do need to deal with fractions every once in a while. I mean, just open up a tape measure. There's fractions all over it if you go into building. So what do we have? Well, we've got these 2 values that need to go together. We've got 1x squared minus 4/3 x squared. This time I am going to rearrange things so that they're close to each other. We have negative 1/2 y squared and negative 4/3 y squared. So these 2 terms need to go together. They're like terms, and I keep forgetting the power of 2. Well, these like terms, the 1 and the 4/3, that's a whole number and a fraction. They will not go together unless they have common denominators. So this has a denominator of 1, and I need the 1 to become, I need a lowest common multiple between 1 and 3. What is the lowest number that 1 and 3 will both go into? They'll both go into 3. So I'm going to multiply top and bottom by 3. 3 over 3 cancels out to be 1, so I'm just making it look different. Here I've got a denominator of 2 and a denominator of 3. So what number does 2 and 3 both go into? The lowest common multiple. 2, 4, 3 will also go into 6. So a lowest common multiple here would be a common multiple or denominator of 6, which means this needs to get multiplied by 3 on the top and bottom, and this needs to get multiplied by 2 on the top and the bottom, and we get this. 3 over 3 x squared minus 4 over 3 x squared minus 3 over 6 y squared minus 8 over 6 y squared. So we have our common denominators. Let's add the tops and call it a day. 3 minus 4 is negative 1. So negative 1/3 x squared. And negative 3 and negative 8. Let's not forget, as I am doing, that we want those signs out front. So negative and negative, we're going to add those numbers and keep the signs. So negative 3 and negative 8 is negative 11 over 6 y squared. I'm Mr. True. Go do your homework.